Welcome. Today we are going to be learning about indices. This is going to be the first video in my math crash course. This series is going to be for students who have mock exams and CXC coming up soon. So if that is the case, then I would suggest that you go and watch all the videos in the playlist. So let's just get right into it. So what is indices? Well, indices just refers to the rules regarding powers and exponents. Indices is just a plural for index, which is another word for exponent. So all that being said, let's just get right into it. So let's say that we have a number a, then it's to the second power, and we add it to another number a to the third power. Well, what do you think is going to happen? Well, nothing. It's just going to stay as a squared plus a cubed. Why is this? Because you can't just add powers. However, if we were supposed to try and add the powers, it would have to be not a plus sign, but instead it would have to be a multiplication. When you multiply indices, the powers are added. So right here, it would become a to the fifth. Now, what if they had coefficients? So let's say this is 2a and this is 3a. Oh, that looks ugly. And this is 3a, right? So what would happen is that we also multiply the coefficients. You should always remember to multiply the coefficients, because if you don't, that's just going to lead you into a whole host of wrong answers and problems. So this is going to be 2 times 3, which is 6. So a squared times a to the a cubed, that is going to be a to the fifth power. So that's our answer. Now we know how to multiply indices. So let's say that we have a to the fourth raised to the second power. What do we do here? A lot of people would just assume that we can't raise something to something that has an index to another index. That makes no sense. But really it does. It's just as simple as just multiplying it. So this is going to be a to the 4 times 2. So a lot of the time you may want to write down as a to the 4, as a to the 4 times 2 right here, so that you can really have it look a lot more simple. And so this is just going to be a to the 8th power. That looks a lot. It's going to be a to the 8th power. Good. So now we know how raising it to another power works. But once again, what if we have a coefficient? So let's say we have a coefficient. Let's say that we have a coefficient of 5 right here. A really common mistake that I'm sure many of you may be guilty of is that you just leave the coefficient alone. But we are applying the power to everything inside the brackets. So let's imagine this 5a as instead 5 times a. So you see how we had to put this power up here for a to the 4th? We have to do the same thing for the 5. It's going to be a to 5 to the second power. I'm sorry. So it's going to be 5 to the second power. So 5 to the second power, we should know that that's going to be 25. So the answer to this should be, let me erase some of this. So the answer to this should be 25 a to the 8th. So now that we understand how these operations work, let's get on to some more complex rules. But we have to start with the simplest one first. Let's say that you have something to a power of 0. So let's say let's say we have a to the power of 0. Well, it's just a fact that you have to get familiar with it. That something raised to the 0th power is just going to be 1. It's not going to be 0. It's just going to be 1. Just remember that it's going to be a 1. It's going to be very, very useful. It's going to save you from a lot of trouble of being confused on your exam. Just remember it's going to be 1. Think of it as just like a fact that how 1 plus 1 equals 2. Something raised to the 0th power is 1. So now what about something raised to a negative power? Well, when something is raised to a negative power, let's say to the, oh Lord. So what about when something is raised to a negative power? Well, when something is raised to a negative power, it is going to be 1 over that number or that variable with that power. Now, to many of you guys, you are going to be thinking that this is absolutely whack. Like, what sense does that make, right? But really, it does make sense. So many of you guys may be doing physics currently. If you are doing physics, I have a new series that's going to be coming out soon, just like this, but for physics. So imagine when you raise something to the power of -1. This is called inversion. So when we inverse something, it's just going to be 1 over that. But we can imagine this, since it's to the -1, we can just imagine this as 1 over a to the first power. Now you see how this works? Alright, so now that we know how raising something to the negative power works, let's try it with a fractional power. So let's say that we're raising something to a fractional power. So let's say like what? 1 over 2. So a to the 1 over 2 power. What's going on here? It's really simple. This is just going to be the square root of a. It's really easy to just remember this as a fact, but for those of you who are watching who would like to understand it a bit more, one way that you can look at it is that it's similar to inversion. So you see like how 1 over 2 is basically the inverse of 2. What's the inverse operation of raising something to a power? Square rooting it. Just like how if you were to raise, like, let's say the square root of 2 to the second power, you just get that 2. That kind of proves that it's an inverse. So this is how you raise something to a fractional power. However, what if we have a non-1 numerator and a non-2 denominator? So let's say that we have a to the 3 over 5. Well, what's happening here? Well, it's also really simple. What's going to happen is that we draw back the roots. However, the denominator is going to be the root that you're dropping it to. So it's going to be 5 out here. And on the inside with the a, it's going to be the 3. So once again, it might not be making sense to you guys, but I promise it does make sense. Watch. So you see how this is the square root of a. Let's look at it another way. This is going to be the second root of a to the first power. The numerator is going to be the power and the denominator is going to be the root. You see, it's really, really, really simple, you know? Just have to follow along and pay attention as you're going along with it. So now that we know how raising something to a negative power and how raising something to a fractional power works, what if you were to raise it to a negative fraction? That sounds a bit tricky, right? But once again, I promise it's really not that hard. Indices is one of the easiest areas of math once you grasp it. That's why it's important to just touch upon your skills once in a while. So let's say that we have a to the negative half. Well, what we do first is that we have to deal with the negative first, okay? So this a is going to be the inverse of a. The inverse being 1 over a. However, we can't forget that we still have that half, even though we did deal with negative, right? So this is going to be the square root of 1 over a. And you see? Really, really, really simple. Oh, my bad if my a kind of looks like a 9. Let me just erase that right there. So you see, it's really simple. So a question that you might get very, very often. I'm looking in my notebook from ways back and I'm still seeing a question like this. The question that I see right now is 2 to the 3x power is equal to 128. What in the world is this? What do you mean to the 3x power? What we're doing right now is that we're trying to solve for x. How are we supposed to solve for x in this case? It's not really difficult, but you have to follow along. You really need to follow along. You can't afford not to. So what we're going to do is that we're going to try and drop 128 to the same base. So 128 is just another way to say 2 to the 7th power. What? 2 to the 7th power. So now that we know that it's 2 to the 7th power, we can say, okay, so this is going to be 2 to the 3x power is equal to 2 to the 7th power. So since we're trying to just find x, one thing that we can do is, since that both of them are at the same base, we can simply cross out the bases. The bases don't really matter here. So that means that we can simplify this equation to 3x equals 7. So how do we solve this equation? It's really, really, really simple. We just divide 7 by 3. So 7 divided by 3 is going to be x. So therefore, 2 to the 3 times 7 over 3 is equal to 128. What? That's what I'm saying. This is why it's very important to understand the rules of indices. Like, this is a light problem, right? We're going to end up doing something that's a lot more complicated. Okay, so a question that I am seeing right now, apologies for the construction or whatever that is going on in the background, but a question that I am seeing right now goes like this. So in brackets, brown color, let's say in brackets, we have 4 to the x power multiplied by 8 2x plus 1. Oh, that plus don't even look like a plus. Multiplied by 8 2x plus 1 is equal to 64. Whoa. So let's take a step back from this and understand what's going on before we get overwhelmed by the numbers. So what we're trying to do here is that we're trying to find x once again. So now that we know that we're trying to find x, well, just following the steps that we used before, we're trying to get everything to the same base so that we can cancel them out and just work out a much simpler equation. So let's take a look at this. So we have 4, 8, and 64. Those seem very familiar, right? These are all powers of 2. 4 is just 2 to the 2nd power. 8 is just 2 to the 3rd power. And 64 is just 2 to the 6th power. Whoa. Okay, so now we can make some progress, right? So let's keep them in the brackets and say what? So 4 is just going to be 2 to the 2nd power, right? But we have to keep this in brackets as well, right? Because we have to raise 2 to the 2nd power to the x power. And then same thing over here with the 8. 8 is 2 to the 3rd power. And then we're going to be raising the 2 to the 3rd power to the 2x plus 1 power. And then over here, we can just write 64 as 2 to the 6th power. All right. This is workable now. We kind of understand what we can do. So following the law of multiplication of indices that we worked through earlier, where if an index is raised to another power, we multiply the powers. Then we can say that over here in this bracket, it's going to be 2 to the 2x power multiplied by 2. So we're going to be multiplying 3 and the entire 2x plus 1. So this is going to be multiplied by 2 to the 6x, 2 to the 6x plus 3. And that's going to give us 2 to the 6. Okay, so what we can do here, even though we can drop the bases, is we have to recognize we can simplify this a bit more. How can we do that? So we have 2 powers of the same base, 2 numbers of the same base being multiplied. So what we can do is that we can add the powers together. So we can say 2 to the 2x plus 6x plus 3. We can just add the like terms and say 8x plus 3 is equal to 2 is equal to 2 to the 6th. So now we can drop the bases because this is as simple as we can get it. So we can drop the bases to say 8x plus 3 equals 6. We move over the 3 first, so we're subtracting 3 from both sides. So this is going to end up become 6 minus 3, which is 3. Oh, it's getting a bit low on the screen. So what we have now is basically 8x equals 3. So what do we do? Once again, we're just going to be dividing both sides by 8. And therefore, x is going to be 3 over 8. You see? Let's go through this one last time. So first, what we did here is that we recognized that we could put all these numbers down to the same base. And so we did, but we did pay attention to the fact that we also had to raise those numbers to another power. So we kept those in brackets so that we remembered what we have to do. Afterwards, because we're raising these exponents to other powers, we multiplied those. So we ended up getting 2x and then 6x plus 3. Why 6x plus 3? That's because we remember that we had to multiply the 1 over here as well. Okay. So when we got finished with that, we realized, oh, okay, we're multiplying two numbers at the same base. So that means that we can add the exponents. And so we did. We added the like terms of 2x and 6x to give us 8x. And we had the 3 as well. So that would be 8x plus 3. And then that's as simple as we could get it. So we dropped the base. I could make a joke about that, but I won't. So we dropped the base, we subtracted 3 from both sides, and then we divided both sides by 8 to get x by itself. My apologies. And then we were finished. We determined that x is equal to 3 over 8. You see? If you guys followed along for so long, I'm really proud of you guys. If you were able to understand this means that you're basically ready for whatever them throw at you for an exam. But once again, I would suggest that you guys go take up on the maths book and practice some more. This is just a video going over how indices works as a part of my math crash course series. So if you are interested in more, please go and look at the playlist if you want to see my newest videos right as they drop. You know what to do. All right, so with all of that being said, thank you for watching and bye-bye.